Feature detectors. Welcome friends in this session of feature detectors. Features are nothing but the characteristics of object, and features are the most important tool in computer vision to detect the objects. Features are, for example, can be a line, can be a small point, can be a triangle, can be a square, or can be an edge, or etc. Can be a color. By finding the features in a given image or in a given video, it is possible to detect the object of interest. It is possible with the help of features to classify the object. It is also possible with the help of features to track the object. Therefore, features are very important tool in the field of computer vision for object recognition. Features are unique characteristics which are identified in a given image, which is further used for a detection or identification of an object. So in this session, we will discuss what is a feature, how they are identified, how to detect the features, and how they are useful in computer vision for detection of a specific object. So let's consider this slide. Let's consider the image on the left hand side. We have to identify the object of interest, and you need to find out what are the good features in a given image. So in this specific image, the point can be a feature. So you have to identify the points which are unique. For example, the points which may fall on this edge. So their way I can identify many points over here, so which are shown in the square boxes. On the other side, if you see this image on the right side, my object can be detection of a text written, or the object can be a color or some patch. In that case, I can detect my feature as, say for example, this straight line, which signifies that this is a letter B, or I can consider the feature as the color. I need to find out the green color tags, or any specific arbitrary object I wanted to consider. So my features can be a region like interest operators. So any region of interest I need to find out, I have to design my feature accordingly. So your feature can be your region of any arbitrary shape, or your feature can be a point. Here in this slide, my object can be to detect a human face. So I consider edges as my important features. Friends, edges finds extensive application in computer vision to detect the objects with diversity, and edges have been proved their robustness in identifying the objects. On the other side, if you consider the image on the right hand side, my feature can be a straight line. So I need to detect the object which is a building or a particular part of the building. So here I can track multiple blue lines, multiple green lines. I can identify vertical lines. I can identify the lines with some angle. So this way, the object of interest which I wanted to recognize, my feature could be a straight line. So once I identify the straight lines, I mean my object has been detected. So here, point features can be used to find a sparse set of corresponding locations. For example, I have one image, and in an image there are specific set of points which are present, and I don't have any other object of interest which is present in a given image. So in order to detect the object which can be of any shape, I am finding over here the 3 points of interest which will provide me help in detection of the object. A sparse set representation means in a given matrix, in a given data, there are minimum ones and maximum zeros are present. Points and patches, they have used extensively to perform object instance or category recognition. Any object at a particular location can be easily identified and it can be classified correctly. Let us consider one example. For example, we are interested in finding the location of stars, or we need to identify a group of stars in the space at night. You will find on the left hand side this image. It has the picture of stars and some region is identified over here, which are the group of stars. And what I do, that I need to track these group of stars every night. So what I do, once I capture the image, I locate my stars at point A, B, C and D. And what I do next is that with some reference I calculate the distance of point A, point B, point C and point D. And once I have set of these distances with me, I immediately track the specific stars every night, whether they have moved from a location to another or any other change or any other pattern I am interested in. So while identifying the stars at night, I may find the point features are extremely useful for me. It also permits matching even in presence of clutter, that is occlusion, and large scale and orientation changes. So inherently the points and the patches are nothing but the collection of points or the group of points. So even in the presence of some occlusion at a large scale or any orientation, inherently the points and patches shows the robust performance. So my next question is that how to find these feature points. The features can be a line, it can be a point, it can be a patch, or it can be some color. So there are two main approaches that one can use. The first approach, you have to find the features in one image that can be accurately tracked using some technique, say local search technique, such as correlation or least squares. So what do I have? Suppose I have one image and I have some specific set of points with me. So once I identify these specific points, when I have some another image, then I can immediately track these points very easily as shown in this figure. So finding the features in one point can be accurately tracked using some local search technique such as correlation or least square in the second image. Such unique features one has to identify. So finding a set of points or patches would be easy in the second image with some reference. So this approach you can use, and for that the correlation or least square algorithm can be used. Second approach is independently you have to detect the features in all the images under consideration, and then you match the features based on their local appearance. Say for example, I have image number 1, so I am finding whether I can find my object of interest. Then I have second image and I am finding my features, my object with my feature library in the second image. In third image, I have my object over here. So in image number 1, 2 and 3, independently I am applying my algorithm, I am applying my feature detector, and I am finding the object of interest. I do not have any reference between image 1 and 2 and 2 and 3 and so on. So it is per frame estimation of the object approach that is being used. So which approach is to select? The answer is it depends upon the type of application, where first approach is feasible, in some cases second approach is feasible. If you are confused, you have to try out approach 1 and 2 and you have to elect a specific approach where you find you are getting good results. For example, approach number 1 would be useful when you have low diversity in an object detection. There is a more clarity and it is possible to accurately track the features from one image to another image very easily, and it is simple to find out the features in the next image. While second approach would be useful when there is much diversity or variety in a given object, in a given image. So the image shows the variety in the object and there would be some difficulty in tracking of a specific feature in the next image, into the next image and so on. So in that case, you have to work independently per frame and you have to apply the features and you have to get your work done. So friends, in this session we have seen how features are useful in finding the object of interest, and they are extremely important because once you identify the features, it is very easy to detect the object of interest. And there are two approaches which we have seen. In first approach, you have to track the feature from one image to another image, and that would be easy when your objects are simple and there is no diversity. Second approach you have to apply where every independent frame you have to consider, you have to find out the feature and you have to detect the object. So this second approach would be useful. Thank you for the session.